Okay, today's lesson, you're going to need a calculator, and we're going to solve log equations. So make sure you pause the video if you need to go get a graphing calculator. Okay, let's see. I'm going to grab my pens. Let's start in blue. So what we're going to do is we're going to solve equations with x as an exponent. And we've not done this before. We've only solved when x is kind of on the same line as where our coefficients are. The reason why we do logs is that way we are able to solve equations with x as an exponent. So let me give you an example. On number 1, I have 4 to the x equals 32. All right. I can actually use methods that I've done before, meaning I can make similar bases and say, oh, 2 squared is 4, and then 2 to the 5th is 32. So that leaves me base of 2 to 2x is base of 2 to the 5th. And then I say, oh, if the bases are the same, I set my exponents equal. So this is how we've done problems before. I divide by 2, so my answer is 5/2. All right. The issue comes in is, let's look at number 2. 6 to a power is 21. Well, I don't know what power 6 is to in order to give me 21. So in order to solve equations that aren't going to work out nice with the same bases, we need to have a method to solve. So what we're going to do is we're going to use logs. So bear with me to start. I'm going to kind of follow through. What I'm going to do is I'm going to take the log of both sides, meaning I'm going to put log in front of 6 to the x and log in front of 21. And the reason why I'm doing that is because with rules of logs, I can bring my exponent out front. That's kind of my third property of logs. And that allows me to be able to solve for the x. So that's why logs are so important, because the property of bringing an exponent out front, now I have x times log 6 equals log 21. If I'm solving for x, just solve it like a typical equation. I would divide both sides by log 6. And on your calculator, you're going to go to the first, turn your calculator on, you're going to go to the first column, and the fourth button up from in the first column, it says LOG for log. Type in log 21, press enter, then divide by log 6 and press enter. If you do so, I'm going to want you to round to do 2 decimal places. So if I do log 21, I'm going to press enter, and then I'm going to do log of 6. So, sorry, divide that by log of 6, and my answer is going to be 1.699. So let's round that to 1.70. All right, and that would be the answer for number 2. But again, number 2, we couldn't use our old method of finding the same bases. We had to take the log of both sides. Now let's go to number 3. Number 3, if my exponent is already isolated, meaning my base is to the power, I can go ahead and take the log of both sides. So let's take the log of 3 raised to the x plus 4 is equal to log of 601. Again, the purpose of this is to take this exponent and put it out front. So now I'm left with x plus 4 times log of 3 equals log of 601. Because I'm solving for x, I want to get rid of the furthest stuff away first, meaning I don't want to subtract 4. Okay? If I have something times log 3, the first thing I need to do is get rid of that log 3 by dividing. Now to make this a little simpler, most of you may want to actually use the calculator at this step and do log of 601 divided by log 3. Be careful if you do it all in one step that you're putting parentheses over parentheses. Okay? So you can do that and find the decimal, or you could leave what you had and do the next step. I'm going to go ahead and just do that. So I'm going to put log of 601 and press enter. I'm going to divide by log 3, and I get 5.8, and do a couple extra decimal places, so 5.8243. And if I simplify the right side, all I have left is x plus 4. So to solve for x, you would subtract 4 from both sides. So you have that number still on your calculator. Just subtract 4, and I'm going to get 1.82. Oops, hold on. I don't know what just happened, but hold on. There we go. Let's just ignore that. So my x answer is going to be 1.82. All right. Now, if we scroll down to number 4, what's the issue with number 4 is that I cannot take the log of both sides yet. Okay, please make sure you put on your notes that you have to isolate the exponent. And what I mean by that is there's anything that when you have the base to the exponent, if there's anything out front, added, subtracted, multiplied, whatever, you've got to get rid of it. So if I'm trying to isolate this term, I want to move the furthest stuff away first. So I'm going to subtract 1 to start my problem. I get negative 2 raised to the x power is negative 7. Again, this is still not isolated because it's really a number times 2 to the x. I want to divide out that negative 1 because I want to get 2 to the x all by itself. Once I do that, I can follow the steps that I did in 2 and 3 and take the log of both sides. In 2 and 3, it were simpler problems where they were already isolated. Number 4, I've got to subtract 1, divide by negative 1. Now I can do the steps of saying, hey, oh, x is an exponent. I know when x is an exponent, in order to solve, I'm going to take the log of both sides. My properties of logs allow my x to come out in front. So x times log 2 equals log 7, and I'm going to try to squeeze this in. I'm going to divide both sides by log 2. So if I do log 7, enter on my calculator, divided by log 2, enter on my calculator, I get 2.8. It's 0.7, so let's round that up to 2.81. All right? All right, number 5. Is the base and the exponent already isolated? Meaning, is there anything 4 to the power? Is there anything added, subtracted, multiplied, or anything else? The answer should be no, there's not. So I can start by taking the log of both sides. So I take the log of 4 to the power equals log of 92. Make sure you do both sides. Otherwise, if you have an equation, in order to keep it equal, you have to do the same thing on both sides of the equation. Let's go ahead and bring the 3x plus 1. I'm going to put it in parentheses. 3x plus 1 times log 4 equals log 92. And this is sometimes where we get confused, but move the furthest stuff away first. I don't want to subtract 1 or divide by 3. I want to isolate this stuff, so get rid of the log 4 first. So divide by log 4, and I'm going to find out what that is, meaning I'm going to press the log of 92 on my calculator, divide by log of 4, and I'm going to get, let me leave this a minute, 3x plus 1 equals, I'm going to get 3.2617. And from there, now I kind of have an algebra 1 equation where if I'm solving for x, I'm going to take away 1. So I have 3x equals, take away 1 on your calculator, I'm going to get 2.2617, and then divide by 3. So my x is going to equal, let me scroll down a little bit, x is going to equal, divide that by 3 in my calculator, I got 0.753, so let's do 0.75, and I'm done. Right, go ahead and try number 6 on your own. Go ahead and see if you can isolate that, take the log of both sides and solve. Press pause on the video, and when you're done, come back to check your answer. All right, number 6, the first thing you should have done is to isolate the base to the power. So if I subtract 7, I get equal to 13. I'm going to take the log of both sides because my x is an exponent. And I know if x is an exponent, if I take the log of both sides with properties of logs, I can bring whatever the exponent is out front. So I'm going to bring that out front, and now I'm solving for x, so I'm going to divide by log 2. So on my calculator I have log 13, I'm going to divide it by log 2, I'm going to leave the left side, which is x over 5, I'm going to get 3.700 and so on, that's probably good enough. And if it's x divided by 5, you have to do the opposite operation. Well, x divided by 5, let's multiply by 5. So I'm going to multiply by 5 on my calculator and get 18.5. So we have 18.50. All right. So those are 6 examples of how you can solve problems when x is an exponent. Make sure that you isolate the base to the power before you take the log of both sides. That's one of the biggest keys. All right. The second part we're going to do, part B, is we're going to solve equations with log already in the problem. All right. And kind of what we talked about before with logs is if we can get rid of the logs, it makes it a lot easier on us to solve. All right, so number 1 is kind of a special case. If I have log base 4 of something equal to log base 4 of something else, what is going to have to be true of those somethings? So if I have log base 4 of something and equals log base 4 of something, what's on the left, that something is going to have to equal the something on the right. So you can actually just drop out those logs. This is using more common sense. This is not necessarily like a mathematical property, more than just knowing rules of equality. So if I know I have log base something of a number equals log base something of a number, those two things must be equal. So if I set 3x equal to 2x plus 3, if I take away 2x, my final answer is x is 3. So that one was a piece of cake. All right? Just be careful that these logs, the bases have to be the same in order for that to work. If you look at number 2, you can see we only have one log. Well, if we think about what we've learned about with rules of logs and how we can get rid of logs, we know that by the circle method, I can take a log and create it into an exponential function, all right, because they're inverses of one another. I'm going to take the base to this number, and it's going to equal this, meaning I'm going to have 4 to the third power equals 2x plus 4. That's how I can rewrite my log function into an exponential function. So if I make my log equation into an exponential equation, now let's just solve for x. Well, 4 to the third power is 64. And now you can see the algebra is going to be pretty easy. I'm going to subtract 4 from both sides. So I'm going to get 60 equals 2x. If I divide by 2, I will get x is 30. All right, so if you have a single log, you can use the circle method to change it into an exponential equation and then just solve for x. Now, with the third problem, this one's a little bit tricky because I have a log x, another log x. I don't know how to get rid of logs when I have multiple logs. Okay, I can't do that. So what I want to do to make life easier is I know number 2 is pretty darn easy if I got that log by itself. So what I need to do, and please put this on your notes, is you want to get one log. So however you need to do that, you need to get one log in order to solve. Now, number 1, that was not needed because that's a special case, right? But for most of the problems, in order for me to solve, I'm going to have to kind of condense, that's why we did condensing, to get one log because I cannot make a circle the way number 3 is right now. Now, number 3 actually have 2 properties I'm going to use. One of the properties is if I have an exponent out front, I'm going to bring it up top. So when I condense, I bring that up top. So I'm going to start with that. So that's really log of x squared. Another rule for condensing was if you have addition of logs actually means multiplication of logs. So I'm going to take x squared times x. Okay, and that's the property of multiplication and addition with logarithms. So if I simplify this, I'm going to get log of x to the third equals 3. Well, that's great because now I can make my circle and change this log equation to an exponential. Does anyone remember what your base should be if it's not written there? Hopefully you said 10. If nothing's written, it's assumed log base 10. So put in your base 10, make your circle, say 10 to the third is x to the third. And some of you can look at that and say, wait a minute, if it's something to the third equals something to the third, then x is going to have to equal 10. And that's exactly right. Some of you might actually work it out and say, okay, x cubed is equal to 1,000, right? What is the cube root of 1,000? Well, that's really 10, because 10 times 10 times 10 is 1,000. So however you want to figure it out, you can get to the answer x is equal to 10. All right, let me go back to number 4. We kind of had the same issue. I cannot make a circle until I have log base of something equal to something. So I've got to make sure that I subtract this 2 first. All right, make sure you guys get it in your brain that you've got to isolate. So log base 3 of x plus 6 is equal to 6. And now what's nice is if I have log base of something equals something, I can change my log equation into an exponential equation. So 3 to the 6th equals x plus 6. I'm going to use my calculator and say, okay, what is 3 to the 6th power? And that's 729. So 729 equals x plus 6. If I subtract 6, just take 729, subtract 6, and my answer would be 723. All right. So I actually think part B is easier. Once you learn and recognize how to condense to a single log, creating an exponential is easy. All right, last 2 problems. Go ahead and try number 5 on your own. It is already condensed to a single log, so you can just make your exponential and solve. Go ahead and press pause on the video and come back and complete that problem. Okay, so for number 5, hopefully you started out by making an exponential equation. 2 to the negative 1 equals 2x minus 3. Now, we know 2 to the negative 1 is really 1/2, and you can write it like that, So hold on, sorry, 1/2 equals 2x minus 3. You are going to have a calculator. So if you did that on your calculator, you also would get 0.5. It doesn't necessarily matter which one you do. Some of you are probably going to be more comfortable with the decimal. And at this point, it's fine because most of my solutions are going to be decimal answers. So if you wanted to change 1/2 to 0.5, that's fine. Go ahead and just solve for x. And I'm going to get 3.5 equals 2x. And if I'm solving for x, I divide by 2. So on my calculator, I'm going to do 3.5. I'm going to divide that by 2 to get 1.75. And again, if you guys can round to 2 decimal places, that would be great. Okay, last problem, number 6. If you look, I am not a single log. I cannot start making a circle here until I have one condensed log. So if I look at this, I say, wait, it's log base 2 of something plus log base 2 of something. I know when I add, what I really can do is when I add logs, I really can condense them by multiplying them together. So I'm going to put log base 2. I'm going to multiply x plus 2 times x. I'm still going to make it equal 3. I'm going to simplify that before I make my circle. So I'm going to get x squared plus 2x. And I'm just putting in parentheses just to, I feel like, make it visually easier to see. Now that I've condensed to one log, I can create my circle and solve. I can say 2 to the third equals this. So I'm say 2 to the third equals x squared plus 2x. So I get 8 equals x squared plus 2x. But in this example, I'm going to have to do a little more work. I have an x squared and an x and a number. And we should know by now that if I have a square term, an x term, and a number, I've got to move all of it to one side, and we're going to have to factor. So I'm going to put factor here. We're going to have to factor this example in order to solve. Go ahead and say what multiplies to give me negative 8 and adds to give me 2. Well, what two numbers multiply to give me negative 8 and add to give me 2? That would have to be a positive 4 and a negative 2. So if I solve these, this would give me negative 4, and this would give me positive 2. Now we've mentioned this before. I cannot take log of a negative number. If I look at my original problem, if I plugged in negative 4 and put it here, it would wind up being log of negative 2. Or even if I plugged it in here, it would be log base 2 of negative 4. I can't take log of a negative. So you're going to reject this solution. If you don't believe me, you can even put on your calculator, just put like log of negative 4. You're going to get an error where you have a non-real answer. 2 will work, so that will be the one solution to your problem. Okay, so take a look at these. Again, review them again if you need, and we will work on solving log equations in class tomorrow.